focused discussion of the hip joint kinematics, kinetics, and EMG during walking. So we'll start with the hip joint angles. You see the knee and the ankle here, and then we can see the hip joint angles here in the upper right. And the various lines are because of different speeds. And we can see that the hip starts at initial contact, which is 0 here, and then the subsequent initial contact is 100. So this constitutes one gait cycle. We can see that the hip starts at initial contact in 30 to 40 degrees of flexion depending on the speed. Higher speeds, you get higher hip flexion angles. Essentially, the increased hip flexion angle at initial contact increases the stride length, which contributes to faster speed. So we can see that essentially initially, irrespective of speed, there's as the person lands in the first 5% of stance, the hip angles don't really change very rapidly. They're fairly flat. And then after about 5 to 10% of stance, after the weight acceptance phase is completed, we see a rapid hip extension to the point where as you get into terminal stance, you have about 10 degrees of hip extension. And then as you transition from pre-swing here to swing phase, we see this rapid hip flexion until terminal swing when it plateaus. So now we want to understand the moments or the agonist muscle activity that controls that hip motion. So here we have the moment data. We have an extension moments are positive and flexion moments are negative. So we have 2 extension moments and 1 small kind of gradual flexion moment. So from initial contact to weight acceptance, with the ground reaction force is anterior to the hip joint center, and therefore the hip extensors are active, and up to about 20% of stance, 15-20% of stance, they remain active. And so this rapid hip extension we see here is a product of this hip extension that occurs early in the loading response and then early mid stance. So in late mid stance here, the ground reaction force is transitioning to being posterior to the joint center. So as the body center of mass passes anterior to the foot, okay, which is the definition of the mid stance transition to terminal stance, as we get into that position, the ground reaction force is going to pass posterior to the joint center, and therefore there will be the control switches to the hip flexors. And so the hip flexors really turn on strongly as we get into late terminal stance and pre-swing. And so they're going to contribute, like one of the hip flexors being the rectus femoris, and that's what we see here during pre-swing, that's going to contribute to this strong hip flexion and this rapid hip flexion here that occurs as we start into the swing phase of gait. We can see that kind of illustrated in this diagram as well. And then finally, as we go into terminal stance, I said it wrong, terminal swing. As we go into terminal swing, we see this large hip extension moment, and essentially the hips being swung forward, and as the hips being swung forward, the hip extensors, the hamstrings, which are one of those, and note that they're also acting at the knee joint, they slow down the progress of this rapid hip flexion, and we can see it kind of plateaus here in terminal swing. That's because of this hip extension moment. So now if we match up the moments and the muscle activity, we can see that this initial hip extension moment is taken care of by the glute maximus hamstring muscles here, and then the hip flexor moment here in terminal swing is really the the primary focus of the iliopsoas muscle, but in order to record activity from that muscle, we need indwelling electrodes, which are not shown here. And then as we transition to terminal swing, we can see this particular phase is met with a large hamstring activation, and then there's some preparatory gluteus maximus activation right at the transition to the next heel strike phase. So the hip powers, which are demonstrated in this curve, show us which muscles are eccentrically or concentrically acting. So this H1 power here is associated with nearly isometric. I mean, there's some concentric average, but notice that the standard deviation bars here on either side of the concentric or eccentric power curve. So this being concentric positive and eccentric negative. On average, there's some concentric element to it, but it varies quite a bit. So the second burst, which is this kind of eccentric control from the hip flexors, notice that this is pretty consistent, like especially at the transition from terminal stance to pre-swing. And then as we get into pre-swing and the swing phase, we see this large burst, concentric burst, and notice that this is very consistent in terms of getting the hip move forward. And this burst is associated with causing, and this is not a mistake, knee flexion. So the knee flexion that's occurring at the knee is passive, and so this peak 60-degree knee flexion that occurs is dependent on this hip H3 burst, this concentric hip flexion that begins in pre-swing and then peaks slightly after pre-swing. That's what passively flexes the knee as we go into swing phase. And then we can see this late burst here in terminal swing, which accounts for the slowing down of the hip flexion that's going on in terminal swing. So what's the hip extensor role in terms of controlling the knee and during the period from foot flat to the end of mid stance? That's what this is about. So after foot flat, tibia must be stable for the femur to rotate forward. So we've been focusing on this concept where the femur starts here at 15% and then has to rotate all the way to extend the knee and move the trunk in front of the foot. So now we're into past the mid stance, 30% point of the cycle. So we've been through different contributors to this part of the gait cycle because it's a key place where function breaks down during gait. We notice all these different things that are happening. The tibia has to be stable, the knee extensors rotate the femur forward, but we also note that the hip extensors assist with the knee extension. And so essentially our list of possible things that could go wrong in this mid-stance phase are the tibia is not stable, the quad is weak, ankle motion is restricted, and now we have a fourth item, we have hip extension weakness. So all of those things could contribute to some kind of breakdown in the gait kinematics and kinetics at the point from foot flat to mid-stance. So speed matters. Gait speed is a key indicator of clinical status for a variety of medical problems. So the goals of gait is forward progression. And notice that the phase of gait that's key is single limb support. It's single limb support that you have the primary amount of your transitioning of the pelvis forward, and the double limb support phases are what smooth out the transition of the pelvis and the trunk as it moves forward for a smooth ride for as we move through gait and progress forward. And so tibial stability, knee extension, hip extension, and pelvic movements all contribute to gait speed. So at the hip joint, what to look for in terms of contributors to abnormal walking. Decreased hip flexion and initial contact can be a sign of stability or hip weakness. Decreased hip extension and at terminal swing can also be a sign that the person can't control the eccentric control of the hip flexors, can't eccentric control the positioning of the trunk anterior to the foot. And then decreased hip flexion at mid-swing can be a significant contributor to lower hip or knee flexion, and therefore tripping problems because the limb doesn't become short enough when they're in swing.